Hi everyone. In this video, we're going to be doing A-Level Further Maths 9231, paper 14, Further Pure Maths 1, October, November 2025. This paper is 2 hours long, so we'll try to finish within that time limit. And before we get started, I would like to tell you guys about this YouTube channel that you should check out if you speak Hindi or Urdu and you're doing A levels, specifically A level STEM subjects, as well as those same subjects in O levels, such as physics, chemistry, biology, and maths. They're going to be adding more subjects in the future. So stay tuned for that. And the channel that I'm talking about is the STEM Institute. So if you think that would be helpful for your revision, please go check them out. And yeah, with that, let's get started with the first question. Okay, so for this first question, we are told to prove by mathematical induction that this statement is true for all positive integers n. So all positive integers n just means n is more than or equals to 1, okay? All right, so for mathematical induction, we first need to know our general process. So the general process is you first let n be your initial value. In most cases, it's 1, but sometimes it can be 2. In this case, it's 1. So yeah, the first step is to just let n be equals to 1 and prove that, the statement is true. Okay, so do for the left-hand side first. Yeah, so it's just 6 over 5. And now you do the right-hand side. 1 plus 1 over 5 times 1. So if you evaluate the right-hand side, you're just going to get 6 over 5. So therefore, 6 over 5 is equals to 6 over 5. Okay, sorry, I should change the sign. Yeah. So despite the sign like changing here, it still doesn't change the fact that, this statement is true because, yeah, this inequality sign, as you know, it just means more than or equals to. So as long as it's not less than, like as long as this is not less than this, we're good to go. Okay. So yeah, therefore we can say that case for n equals to 1 is true. Yeah. And yeah, now that's the first step. And now the second step for any proof by mathematical induction question is to make an assumption. So you have to write this in a form of statement. So you just write assume that the statement, in our case, is 6 over 5 to the power of n, more than or equals to, wait, sorry, not n. It's better to use a different letter in this case. Oh, shoot. Okay. Yeah. So as I was saying, it's better to use a different letter. Usually, I like to use K, but you can use any other letter. It's up to you. So yeah, you have to make the statement, assuming that 6 over 5 to the power of K is more than or equals to 1 plus 1 over 5 times K for every value of K. And you also have to define K. So here we're going to write where K is a positive integer. So that would be all for the second step. And now for the final and main step, okay, is to let n equals to K plus 1. Okay, so again, to summarize the three-step process for mathematical induction is first you let n equals to 1 and then you like, work out the left and right hand sides to prove that the statement that they gave is true. And then you make your inductive statement, the assume blah, 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 and you replace the n with whatever letter. Usually we use the letter K. And finally, and the main like part is you let n equals to k plus 1, and you try to make it in this like general form. So this n, you replace it with k plus 1. Same for this n, you also replace it with bracket k plus 1. You have to manipulate your way into that. So that's the three-step process for any mathematical induction question. Okay, so yeah, enough talking. Let's just get straight into business. So for me, I believe it's best to start on the left-hand side because it's much easier to work with. Okay, so here we have 6 over 5k plus 1. So in my opinion, since we have a power that's like a sum, we can use this indices law, a to the power of b plus c, and then we can split it up. So we can have a to the power of b times a to the power of c. So this is the law that we're going to use. So therefore, this is just going to be 6 over 5 to the power of k times 6 over 5 to the power of 1, which is just 6 over 5. Okay? And we know from our inductive statement, from a hypothesis, that this has to be true. So let's write that down. And we can also say that and we can also say that 6 over 5 to the power of k plus 1 is more than or equals to 6 over 5 times 1 plus 1 over 5k. Okay? So I know this is gonna be like a bit weird, like it won't make sense because it's not like a usual proof by induction question. But yeah, just bear with me and simplify the entire expression on the right hand side. So doing that, you'll get 6 over 5 plus 1 plus 6 over 25k. Okay? Yeah, I know there's like I know as you're looking at this, you'll be like, okay, there's no way for us to make it into this form. 1 plus 1 over 5 times k plus 1. Okay. I know that. So instead, now we're gonna have to take the right hand side directly. Okay. So yeah, now we're just gonna 1 plus 1 over 5 times k plus 1. So now we're going to simplify this. Okay. And after simplifying this, we're going to somehow prove that this is bigger than this 1 plus 1 over 5 times k plus 1. Okay. So let's just simplify. So 1 over 5 times k plus 1 over 5. So yeah, we get 6 over 5 plus 1 over 5k. Yeah, so we can clearly see that the first number, 6 over 5, is the same for both this and this. So that's out of the question. So now we only have to compare the second term, which for the first one is 6 over 25k. And for the for the first one is 6 over 25k. And for the second one is 1 over 5k. And, just by changing the denominators, you can see that this is clearly bigger than this. All right. So yeah, we can therefore confidently say that 6 over 5 plus 6 over 25k is more than 6 over 5 plus 6 plus 1 over 5k. Wait, actually, no, I don't think I should write that. Let's just write it in the unsimplified form. Okay, so this, oh shoot. Yeah, so this is obviously just more than 1 plus 1 over 5 times k plus 1. Okay, yeah, so by using a bit of logic, we've already decided that this is bigger than this. So obviously that would make 6 over 5 to the power of k plus 1 more than 1 plus 1 over 5 bracket k plus 1. And to match with our statement that we're trying to prove, we have to put the equal sign. It doesn't change anything. Okay? So we can write shown in here. And this is the final step. Okay? You shouldn't miss this out. You have to write your conclusion. Hence, by principle of mathematical induction, okay, actually, I think I should put this. Yeah, because this 3 dots means hence. Okay, so hence by principle of mathematical induction, the above statement is true. Yeah, so we can stop here for the first question. Let's move on. Oh, damn. Okay, yeah, so we can stop here for the first question. Let's move on to the next question. Okay, so for the second question, this is a sum and product of roots question. So we're given a cubic equation, a general one, where d is not equals to 0 and has roots alpha, beta, gamma, such that gamma is 1 over beta. So this is the important part that we have to use. Okay. So yeah, for the first part, we are told to show that beta plus 1 over beta is d minus b. Okay, so okay, first of all, to start with this, there's already a clue in the answer that we have to show on the right hand side, d minus b. Okay, so since there's only d and b, we have to find expressions for those in terms of the roots alpha, beta, and gamma. Okay. Okay, so for b first, okay, so since b is the, how do I say? Since b is the coefficient of the term whose power is 1 less than the degree of this equation, which is 3. So this applies to all equations, quadratic, cubic, and quartic. Okay, so the general is minus b over a. So a is the coefficient of the x cubed term, or the term that whose power is equal to the degree of the equation. Okay, so minus b over a is always equals to the sum of the roots. So in this case, it's equals to alpha plus beta plus gamma. Okay, and since we have this equation here, gamma equals to 1 over beta, this is also equals to alpha plus beta plus 1 over beta. Okay. And since our a is just equals to 1, we can just write this as minus b equals to alpha plus beta plus 1 over beta. So yeah, this is our first equation. Now let's do it for the second, for d. Okay. So to remember this, Okay. So, like just now I said that like the coefficient of the term whose power is one less than the degree of the equation. So the degree in this case is 3. So one less than that is 2. So in this case is the coefficient of the x squared term. Yeah, it's minus b. Like that's the case for all equations. So it actually like alternates, okay? So in this case, your minus b is the sum of the roots, and then positive c is the sum of the root pairs. So for the cubic cases, alpha plus beta plus alpha gamma plus beta gamma, and then it goes back, it alternates back to minus d over a. In this case, a is 1, so it's just minus d being equal to the product of the roots, alpha, beta, gamma. Okay? So this rule applies to both cubic, quartic, and quadratic equations. Okay? So yeah, minus d is equals to alpha plus, no, sorry, not plus. Why am I saying plus? Just alpha, oh shoot, okay. Just alpha, beta, gamma. Okay? So yeah, this is just alpha. Yeah, again, we're going to substitute gamma equals to 1 over beta. So this is just going to be alpha times beta plus 1 over beta. So obviously these two cancels out. Therefore, we're just left with minus d being equal to alpha. Okay, so that's our equation 2. And now we're going to do d minus b. Okay, so d minus b. So d, we can just do negative 2, and then minus b is just plus 1, okay? Yeah, so doing that, it gives us minus alpha plus alpha plus beta plus 1 over b. So minus alpha plus alpha, those two cancel out, and we automatically have d minus b equals to beta plus 1 over beta. And if you, yeah, so that just gives us our required result, which is beta plus 1 over beta is equals to d minus b. So you can write shown here to conclude your answer. And with that, we can move on to the next part. All right, so now we're also supposed to show another result, again for beta plus 1 over beta, but this time we have to do it in terms of C and D, okay? So obviously by now you should know what that means. We have to find an expression for C as well in terms of the roots, okay? So just like what I said in the previous part, C is like C over A. So A is the coefficient of the term whose power is equal to the degree. So since the cubic equation, that term is the cubic term, x cubed term. So the coefficient of that is A. So C over A, where C is the term of the linear, C is the coefficient of the linear term in the cubic equation, the coefficient of the linear term, sorry. Yeah, so C over A is equals to the sum of the root pairs, okay? So you try to like combine, the roots into unique pairs, okay? And you'll see that you'll end up with these three pairs all the time. Or in summation form, it's just sigma, alpha, beta, okay? And this summation form you can use for, um, quartic, cubic, as well as quadratic equations, okay? So I'm getting back to the point. Yeah, C is equals to the sum of the uh, root pairs. Yeah, which is this basically. Okay, so enough talking. Yeah, let's just get into solving it. So alpha beta alpha gamma plus beta gamma. So now we're going to put the 1 over beta. Okay, so this just going to be alpha beta So gamma is 1 over beta plus beta, and then gamma 1 over beta. So the last term is just 1. Yeah, so after simplifying and all that, we get alpha beta plus alpha over beta plus 1. Yeah. Okay. So I think we can stop here. Wait, actually, if you realize, okay, the first two terms, they actually have a common factor that we can factor out, which is alpha, okay? So we'll do that for only the first two terms. So doing that, you'll get alpha beta plus 1 over beta. So yeah, you can see the expression in the bracket is the left-hand side, right, of the whole thing. Yeah, so alpha or beta over 1 over beta plus 1. Okay, so this is our first equation. Yeah, now we'll get the expression for D from the second part, okay? So minus D is just equals to alpha, okay? Um, yeah. Okay, so what can we do? Okay. Okay, you know what? I think it's a better idea if we just isolate for this term, okay? We just make this a subject, okay? So to do that, yeah, we get C minus 1 equals to alpha times beta over beta plus 1 over beta, and then beta plus 1 over beta is equals to C minus 1 over alpha. So yeah, let this be the first equation, not this one. Okay. And then we get our previous equation that says minus d is equals to alpha. Minus d equals to alpha, that's equation 2. So obviously we can just sub, I have no space, so sub 2 into 1. Yeah, so we'll have beta plus 1 over beta equals to C minus 1 over minus D. And to get a final answer, we can just multiply or divide both the numerator and denominator by -1, which will eventually, let me do it here, give us beta plus 1 over beta equals to 1 minus C over D. So yeah, this is our final answer. We can write shown. Let's move on to the next part. Okay, so in part C, we are given the values for B, which is 3, as well as C, which is -3. And we're told that D is more than 0. And using all this, for the first part of part C, we have to find the value of D. All right, so I know what, okay, so to find the value of D, we have to use the previous two expressions that we found in the previous two parts for beta plus 1 over beta. We'll just equate them, all right? So I guess, just write from part A and B. Yeah, the results from those parts, yeah, we can say that D minus B equals to 1 minus C over D. Yeah, and then now we can substitute the values. So D minus B, so B is 3, so D minus 3 equals to 1 minus C, so 1 minus -3 over D, okay? So simplifying all that, you get D minus 3 equals to 4 over D. And now we just make an equation in terms of D. So multiply both sides by D, you get D squared minus 3D equals to 4. Move the 4 over to the other side, and you get D squared minus 3D minus 4 equals to 0. So we have a quadratic equation, so we're going to get 2 values for D. So whichever is negative, we have to reject because it clearly says that D is more than 0. Okay, so I'm just going to use my quadratic solver to solve this in my calculator. Okay, but you have to like give some working. Okay, so either you can just substitute into the quadratic formula like directly, or you can, factor it using your quadratic solver. So yeah, D minus 4 times D plus 1 equals to 0. So these are the factors of this expression on the left-hand side, okay? So you just equate both of them to 0. D minus 4 equals to 0. You get D equals to 4. And you get D plus 1 equals to 0. And you get D equals to negative 1. So obviously this one is rejected because it's less than 0. And D equals to 4 will be our final answer. Yeah, so this would be all for the first part of part C. Let's move on to the second part of part C. Okay, so for the second part of part C, we have to find the value of the sum of the roots squared. Okay, the sum of the squares of roots. Okay, so to do this, I should like introduce some notation which will make this a lot easier, and which you could apply to, quartic and quadratic equations. So the sum of the squares, okay, so for quadratic is alpha square plus beta square, and for quartic is the same, but you add the fourth root squared, okay? So all those three cases for each of the three types of equation, you can just generally use this notation sigma alpha squared, okay? And this notation is not the same as bracket sigma alpha. So this bracket sigma alpha means the sum of roots. So your alpha plus beta plus gamma, and so on, okay? Is not the same as sigma alpha bracket squared, okay? They're not the same, all right? Yeah, so just a friendly reminder, okay? So yeah, this is the notation that I'll be using from now, all right? So the general formula for this, okay, in terms of the notation that I showed you just now, is bracket sigma alpha bracket squared. So this sigma alpha is the sum of roots, individual roots, not root pairs, not, root, I don't know, triplets for quartic equations, or yeah. So it's just a sum of roots, yeah, alpha plus beta, blah, 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 and so on. Minus 2 sigma alpha beta. So this notation is to signify is used for your sum of root pairs. Okay, so like in the first part, yeah, this is the sum of root pairs. I also introduced a notation there. So for the cubic equation is alpha times beta plus alpha times gamma plus beta times gamma. And for quadratic equations is literally just a product of roots. Yeah, so on and so forth. Okay, so this is sigma alpha beta for our case. Okay, yeah. So with that out of the way, we can just substitute sigma alpha, the sum of roots. So sum of roots, you should know is minus b over a. In the first part, I already went through. All right, so yeah, it's just minus b. So I'm just going to put minus b squared here. And then sigma alpha beta, that is just c, okay? If you want a more detailed video on this topic, please let me know, okay? Yeah. So doing this, you get a b squared minus 2c. And we already given the values for b and c. So you can just directly substitute 3 squared minus 2 times negative 3. Yeah, so you get 9 plus 6. Yeah, 9 plus 6, which gives you 15 as the final answer for this question. Okay. So yeah, friendly reminder again, when you use this notation, it can be applied, for cubic, quartic, as well as quadratic equations, all types of equations. So that's why I highly recommend that you use this notation whenever you're given questions like this. Okay, so yeah, with that, let's move on to the next question. Okay, so for this third question, for the first part, we are told to use standard results from our MF19 to show that this result here is true, where B, C, and they are integers to be determined. Okay, so to do this question, it's really simple. So the standard results that they're referring to, okay, so go to further pure maths, I believe. Yeah, so it's the very first thing under algebra. So you can see there's like expressions for summation. So like there's an expression for the summation of r from r equals to 1 all the way to r equals to n. Same for r squared and r cubed. So using all this, we have to, okay, like, yeah, using all this, we have to find the expression for the general summation in terms of n, okay, using all these results that are given to us. Okay, yeah, so let's get started. R equals to 1 n. Yeah, and then just copy it down. So obviously, we have to expand the entire thing out first. All right. So personal preference, I'm just going to expand these two out first. So yeah, r plus 1 we leave alone. And for this, let's find the r squared term, yeah, which is just r times r. That's just r squared. And then multiply by 2 with r, that's 2r. And then for r, we multiply with 3, that's 3r. So 2r plus 3r, that's 5r. And multiply 2 with 3, that is 6. So this is the final expanded form. Okay, r plus 2 times r plus 3. Yeah, now we'll do the same for this. Okay. If you can't expand it that way, you can just expand the normal way. You expand with each of the individual terms. That's also fine. Okay, so for cubic terms, we're going to find the cubic term first. So we have to multiply r with r squared. So that's r cubed. And for the quadratic term, we have to multiply r with 5r. So that's 5r squared. And for 1, we have to multiply with r squared, which is just r squared. So 5r squared plus r squared, that's 6r squared. Okay. All right. And yeah, for r, we have to multiply, for the linear term r, we have to multiply with 6. So that gives us 6r. And for 1, we have to multiply with 5r, which just gives us 5r. So 6r plus 5r, that's 11r. And the constant term, we just have to multiply 1 with 6. We can't multiply r with anything to get a constant term. So that's just 1 times 6, which gives us 6. Okay. Yeah. So this is where the most crucial part begins. All right. So for summations like this, you know how in, integration and differentiation, whenever you have to integrate or differentiate some, you can just split them up and integrate and differentiate them separately. So, for example, I have d dx x plus x squared. So if I want to differentiate this, I can differentiate x first, and then I can just add it with the derivative of x squared. Yeah, so similarly for summations, we can also do the same. Okay, let me just get rid of this. Oh, shoot. yeah, so summations, I'm just gonna write summation A plus B. We can just find the summation of A plus the summation of B. So we can split them up just like integrals and differentials. Okay. So yeah, this one is just gonna be n r equals to 1 r cubed plus summation of 6r squared. And just like, integrals and derivatives, when there's like a constant term that is not that's not what you're differentiating with respect to. So in this case, whatever term is not in terms of r, okay, it goes outside of the summation. So this can just be 6 times sigma r equals to 1 and r squared. Same for 11r, this just be 11 sigma r equals to 1 and r plus sigma r equals to 1 and 6. Yeah, so 6, yeah, this is just going to be 1. And for the summation of n sigma r equals to 1, you can just replace it with n, okay? Yeah, so we'll do that later. But for now, let's evaluate this, okay? R cubed. Yeah, so yeah, luckily for us, we have the exact expression, okay? For the summation of r cubed from r equals to 1 all the way to n, it's just 1 over 4 n squared plus n plus plus n plus 1 squared. Okay, so 1 over 4 n squared times n plus 1 squared. Let's do the same for r squared. Okay, so r squared is this longer expression, 1 over 6 times n plus 1 times 2n plus 1. Okay, so half n, wait, is it half? Oh no, 1 over 6. Yeah, sorry. Yeah, 1 over 6. Oh my goodness. 1 over 6 n times n plus 1 times 2 n plus 1. Okay. Times 2n plus 1 and then plus 11, and then this for the summation of r is just half n times n plus 1. Okay. Half n times n plus 1 plus 6. And yeah, just as I said previously, the summation of 1 from r equals to 1 all the way to n would just be the upper bound. In this case, the upper bound is n, so it's just n. So it's just 6n. Okay, yeah. So yeah, let's just simplify this. Let's not expand it yet. So 6 cancels out. So this just n times n plus 1 to n. And then this just 11 over 2 n times n plus 1 plus 6n. Okay, so all right, so let's see what the required result that we have to show shows us. Let me get rid of this. So yeah, you can see that they clearly factored out a 1 over 4n. So let's see if the terms here, whether we can factor that out. Yeah, I can see that all the terms here have at least one n, so we can definitely factor that out. And all of them have a constant term, okay? So we can definitely factor out 1 over 4n. So 1 over 4n. So for this is, yeah, for the first term is n times n plus 1 squared plus n, yeah, that's gone. So 1 over 4, since there's no term here, no coefficient, it's just 1, so it's going to be 4 times n plus 1 times 2n. Okay, and then plus this one, yeah, the n will be gone. 11 over 2 divided by 1 over 4, that's 22. Very nice number, 22 times n plus 1, okay? Plus 6n. Yeah, that's just 6n divided by 1 over 4n, which is just 24. Okay, you know what? Let me put a much bigger bracket. Okay, now we're ready to expand everything in this huge bracket that I've created. Oh shoot, we don't have much space. Okay, so let me try to get this done quickly. So let's expand this first. Okay, so yeah, this one you can just use the a plus b squared expression. So a is n, so a squared, that's n squared, 2ab, so 2a, which is n, then b is 1, so 2n plus b squared, which is 1, plus 4. Okay, now let's expand this. We'll leave the 4 alone for now. Yeah, yeah, you can expand it normally. Yeah, I'm gonna do the same thing that I did, forgot when. Yeah, the same thing that I did here, all right? So n times 2n, that's 2n squared. 1 times 2n, that's 2n. N times 1, that's n. So 3n, goodness, 3n plus 1 times 1, that's just 1. Plus, yeah, this one's really simple, just 22n plus 22 plus 24. Okay, okay, now let's do this again one more time. So yeah, this one's just n cubed plus 2n squared plus n. 4 times 2n squared, that's 8n squared. Then 4 times 3n, that's 12n. 4 times 1, that's 4, plus 22n plus 22 plus 24. Yeah, 46. Okay, so now we're gonna add all the like terms. So n cubed, there's only one n cubed. And all the n squared terms is 2n squared plus 8n squared. Yeah, that's 10n squared. And then n is just 1n plus 12n plus 22n, which is 35n. And then the constant term there is 4 plus 46, which is 50. Okay. Yeah, so yeah, I believe, yep, I think, yeah, we fulfilled the condition in here to express it in this form. Yep. Yeah, so I think we're done here for this part. Let's move on to the final part. Okay, so we are we have to express this expression. Sorry, I mean, for this part, we're supposed to express this expression in partial fractions and hence use the method of differences. Okay, this is the keyword to find this summation. Okay, so first things first, for method of differences to work, you have to express it in terms of a sum or a difference, hence why it's called method of differences. And to do that, we have to express it in partial fractions first. So let's set up our partial fractions. Okay. So I'm not going to elaborate much on this because yeah, further math students supposed to have a good foundation, but I will give a brief explanation. Okay. So yeah, since the numerator is a constant and the bottom, if you can't tell, is clearly a cubic expression. So it's a proper fraction. So you don't have to do any division or anything. So you can just straight away just set up your partial fractions. Okay. Yeah. And yeah, so the partial fractions will just be like this. So the first one, the numerator will be a over r plus 1 plus, yeah, because since all of the factors are linear terms, the numerators have to be constants. They have to be 1 degree less than the denominator. Okay, that's the general rule. Okay, okay, so we're done setting up. Okay, Yeah, now we're gonna get rid of the denominator, okay, by multiplying both sides by this denominator, okay? So doing that, we get 2 equals to a times. So multiplying the denominator with 1 over r plus 1, it only gets rid of the r plus 1, but the r plus 2, r plus 3 would stay. So this is just going to be a times r plus 2 times r plus 3. Same for b, okay, since, r plus 2 is the denominator, only r plus 2 will go, so b times r plus 1 times r plus 3. Same for c, r plus 3, so it will have r plus 1 and r plus 2. Yeah, so this is the setup, okay? So yeah, now this is common knowledge. You're supposed to make the factors equals to 0. So I'm going to make the r plus 2 0 by substituting r equals to -2. Okay, so the a would go away, the c would go away, so we'd only have b left. Okay, so b minus 2 plus 1, that's -1. Minus 2 plus 3, that's 1, equals to 2. Yeah, this would just give you b equals to -2. Okay? Yeah, b equals to -2. And now you're supposed to sub r equals to -3. Yeah, so by doing that, a is going to be gone, b is going to be gone, so c only. So -3 plus 1, -2. -3 plus 2 is -1 equals to 2. So -2 times -1, that's 2. So yeah, they cancel out. Therefore, c is equals to 1. And finally, we will sub r equals to -1. Okay. So subbing that, you get, yeah, the b and the c become 0. So you only have a. So a times -1 plus 2, r plus 2, that is just 1. R plus 3, -1 plus 3, that is 2. So that equals 2. So cancel out. Therefore, a, we also get equals to 1. Okay? So yeah, this would be what a, b, and c stand for. And therefore, yeah, our final, not our final answer, but our final expression for this complicated expression is 1 plus over r plus 1 minus 2 over r plus 2 plus 1 over r plus 3. Yeah, so this is the final expression that we have to work with, okay? Okay, now let's bring out the summation. So the summation, yeah, we can just directly replace it with the partial fractions form. Okay, so r equals to 1 and 1 over r plus 1 minus 2 over r plus 2 plus 1 over r plus 3. Yeah, so this is what we have, okay? Right, so now we have to know what the meaning of a summation is, okay? So I'm just going to give a simple example, okay? The summation of r equals to 1 all the way to n of r. It means that r starts from 1 and then you add 2, yeah, because r, and then 3, and you just add all the way until n, okay? So that's what the summation actually means, okay? Because, yeah, so therefore, we're gonna do that. We're gonna substitute 1 first into r, okay? So 1 over 1 plus 1, that's just half 1 over 2 minus 2 over 1 plus 2, that is 2 over 3 plus 1 over 1 plus 3, that is 1 over 4. Okay, So that's for r equals to 1, and then plus, do the same, but replace r with the next number, which is 2, okay? So yeah, you'll get 1 over 2 plus 1. Yeah, 1 over 2 plus 1, that's 1/3. Minus 2 over, yeah, so you can see like the denominators, they actually just increase by 1. So therefore, the denominator here will be 2 plus 1 over 5. So that's for r equals to 2, okay? Actually, I don't think this is a good way to organize it. Yeah, I think there's a better way to organize. Ah, shoot. Okay. Right. So yeah, let's do this again for r equals to 2. So this is 2 over, no, 1 over 3 minus 2 over 4 plus 1 over 5, okay? Okay, let's do a few more, okay, to convince ourselves that there's a pattern to which as to what terms will cancel out eventually, okay? Okay, let's continue. So this one for I equals to 3, 1 over 3 plus 1, which is 1 over 4 minus 2 over 5 plus 1 over 6. Okay, so we can see that our first cancellation of terms, so the r equals to 1, the last term, plus the first term for r equals to 3, 1 over 4, they add up to get 2 over 4, which cancels the middle term for r equals to 2, okay? So yeah, this cancels out. Yeah, the same pattern starts from r equals to 2 for 1 over 5. So 1 over 5, it will add up with the 1 over 5 when r equals to 4, because then with the first term, then you add them up, it becomes 2 over 5, which will eventually cancel this out. And the same will also happen to 1 over 6, right? Okay, so now let's fast forward first and plus the last terms, okay? Okay, actually, dot 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 yeah, dot 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 plus let's do n minus 2, okay? N minus 2. So n minus 2, 1 over n minus 1 minus 2 over n plus 1 over n plus 1, okay? And then minus 1 is 1 over n minus 2 over n plus 1 plus 1 over n plus 2. Yeah, n minus 1, yeah, n plus 2. And then finally we have n, which is just 1 over n plus 1 minus 2 over n plus 2 plus 1 over n plus 3. So yeah, you can see the n plus 1 terms will cancel out, as well as this, as well as this. So yeah, there's a reason why the order of the terms matter. So the first row is for r equals to 1, second row is for r equals to 2, so on and so forth, okay? So there's a reason why you should organize everything orderly, okay? Yeah, so yeah, you can see everything cancels out except 1 over 2 minus 2 over 3 plus 1 over 3 plus this plus 1 over n plus 2 minus 2 over n plus 1 plus 1 over n plus 3. Okay, so yeah, oh my goodness. Okay, so squeezing everything together, I'm just gonna press calculator for the whole numbers. Half minus 2 over 3 plus 1 over 3. Yeah, that just gives 1 over 6. And n plus 2 terms, okay? Minus 2 over n plus 2, minus 2 over n plus 2 plus 1 over n plus 2, that's negative 1 over n plus 2 plus 1 over n plus 3. Okay, Yeah, so this would be our final answer for this part. Let's move on to the last part. Okay, so for the last part, we just have to state the value for the summation of this, but the upper limit is infinity. Okay, so since we know the expression for this in terms of n, we can just put a limit as n approaches infinity to the expression 1 over 6 plus 1 over n plus 2 plus 1 over n plus 3. So this is going to be equals to, okay, so for this, as n gets bigger and bigger, the denominator gets bigger and bigger, the whole number minus 1 over n plus 2 will get closer and closer to 0. Same for plus 1 over n plus 3. As the numerator n approaches infinity, the denominator, gets bigger, and this will also approach 0. So in reality, you have 1 over 6 minus 0 plus 0. So yeah, doing that, the value would just be 1 over 6. So yeah, this would be the final answer for the entire question. Let's move on to the next question. Okay, so for the fourth question, it's a vectors question. So we're told that the points A, B, and C, they have these position vectors. So this is for A, this is for B, this is for C, relative to the origin also. Yeah, this one is OA, this one is OB, this one is OC, okay? So for the first part, we're told to find the equation of the plane ABC, giving your answer in this form. So we have to give a answer in the Cartesian equation form, okay? Okay, so first let's draw a sketch of the plane ABC. So this point A, this point B, this point C. So the plane, it roughly looks something like this. Okay, so to find the equation of a plane, we're supposed to find a vector that is normal to the plane. So a vector that is perpendicular to the plane. And to find a vector like that, we can take two vectors in the plane, like for example, AB and AC. The only condition is that they have to be originating from the same point, those two vectors. So you can take something like AB and BC, okay? So once you find those two vectors, you just find their common perpendicular by taking the vector product. And yeah, by taking the vector product, you will find a vector that is normal to the plane, okay? So our first step is to always find a vector that is normal to the plane. So let's start by finding AB. Okay, so AB is just OB minus OA. Okay, so OB in column vector form. By the way, always use column vector form. It's much more effective. It's just 2, 2, 2 minus OA, which is 3, 5, 5. Okay, so 2 minus 3, that is -1. 2 minus 5, that is -3. 2 minus 5, that's also -3. Okay, and now let's find AC. So AC is just OC minus OA. So OC is 2, 1 minus 1 minus OA. So OA is 3, 5, 5 equals to 2 minus 3, that is -1. 1 minus 5, that is -4. And -1 minus 5, that's -6. Yeah, so these are the two vectors that we're going to use to find the normal vector to the plane. Okay? Okay, so let's find the normal vector. So to find the normal vector, like manually, but you have to arrange your AC. Okay, first you have to, you know what? First you have to get the order right. Okay, so for me, I like to use the first vector AB, vector multiplied with AC. Okay, so once you got the order right, yeah, now you can do it in determinant form. So write down your ijk first and put the ijk components for AB first. So -1, -3, -3, and do the same for AC. So I component for AC is -1, for J -4, for C is -6. Okay. So if you want, you can actually just do all this in your calculator. Like the quickest way I can put it is to go to vector settings by pressing the number 5, like when you press the menu button. Okay, so you can just do that. Like that's all I can say without making this too lengthy. But yeah, I'm just going to show you the manual way. Yeah, if you want a video on how to find a vector product and other calculator shortcuts, please let me know down in the comments below. Thank you. All right, so yeah, it's basically the same as finding your matrix determinant. Okay, so you take your first um, component here at your top left, okay, which is I, and then you cover these two. Okay. Yeah, and then you take your -3. Oh my goodness. Oh shoot. And you take your -3, -3, -4, -6, and then minus J. Okay, so you cover your J from both the row and column, and then you take -1, -3, -1, -6. Okay, so wait, let me just try to erase it without screwing things up. So that's two, two. Okay, good. And yeah, plus K. Yeah, you do the same. You cover these, like the row and column from K, and you take the determinant -1, -3, -1, -4. Okay, yeah, so you can see the process is very similar to finding the determinant of a matrix. Okay, so just cross multiply -3 times -6, that is 18, minus -3 times -4, that's 12. So 18 minus 12, minus J, -1 times -6, that is 6, minus -3 times -1, that's just 3, plus K, that's -1 times -4, that is 4, minus -3 times -1, that's 3. Okay, so column vector form will be 6, 2, 1. Okay, so this is the normal vector, and yeah, I don't think we can simplify it because there's no common factor between the components, so we can leave it as that. So yeah, our left side of the equation is settled. The coefficients A, B, C, they're just the x, y, and z components of the normal vector. Okay. So yeah, we can just write 6x plus 2y plus 1z, or z equals to d. To get our d, we can just substitute the Cartesian coordinates of A, B, and C. Okay, anything. I'm gonna use C. No, I'm gonna use B. We are 2, 2, 2. Okay. So yeah, I'm just gonna say sub B, 2, comma 2, comma 2. Okay, so this is going to be 6 times 2 plus 2 times 2 plus 2. So 12 plus 4, which is 16, plus 2, which is 18. So therefore, D is equals to 18. So therefore, our final answer would be 6x plus 2y plus z equals to 18. Okay? So yeah, this would be our final answer for this first part. Let's move on to the next part. Okay, so before we get started with this part, I realized I made a small calculation error while, while computing this part specifically. So yeah, 6 minus 3, it is 3. And then minus j, that makes it minus 3j. So therefore, the j component or the y component is minus 3. Okay, so the normal vector is 6 minus 3, 1. Okay, so therefore the vector equation is minus, oh my goodness, is minus 3. Okay, let me replace this. Yeah, let me erase this. Let me erase this. Let me erase this. Let me erase this. Okay, yeah, so it's minus 3. So 12 minus 3 times 2, that's 6. 12 minus 6, that is 6. Plus 2, that's 8. So therefore, D is 8. So therefore, our final answer is 6x minus 3y plus z equals to 8. Yeah, this is the final answer. And yeah, please learn from my mistake. Please check your answer with a calculator, all right? Um, yeah, but still, show you're working, okay? Forget what I said before I made this mistake. Like, don't just rely on your calculator. Please show you're working, okay? Yeah, so use your calculator to check to make sure you don't end up making the same careless mistake as me. Okay, so yeah, with that, we can actually get started with this question. Okay, so we are told that the point D has this position vector, and using that, we're supposed to find the shortest distance between the lines AB and CD. Okay, so to do this, okay, this is the most ideal method, okay? So first sketch the two lines, okay, AB and CD. Ideally, they shouldn't both like be the same length because they're probably not. Oh, yeah. So this is AB and CD. And now to find the shortest distance, okay? So the shortest distance is given, like, okay, um, this applies for like both points in your normal A-level maths as well as lines in A-level further maths. So the distance from a point to a line is given by the perpendicular. So the perpendicular is the line that connects the point to the line, and the perpendicular is, of course, perpendicular to the line. So similarly, for the shortest distance between two lines, um, we just have to find the line that is perpendicular to both the lines that we are trying to measure the distance between. Okay, so yeah, we have to first find a common perpendicular between AB and CD first. Okay, yeah. So yeah, let's do that first. Okay, so to find that, let's just find AB. Okay, so AB is just OB minus OA. So OB is 222. Oh wait, we already found AB. What am I doing? Sorry. Okay, whatever. So AB is -1, -3, -3. And yeah, CD is what we haven't found. So CD is OD minus OC. Um, that is OD. Yeah, OD is column vector form I, which is 1 minus j, that's -1, and 3k, that is 3. So yeah, this is OD, then minus OC. So OC is 2, 1, -1. -2, 1, negative 1. Okay, let me double check that. 2, 1, negative 1. Okay, good. So yeah, we can minus this. So 1 minus 2, that is negative 1. Minus 1 minus 1, that is minus 2. 3 minus negative 1, that is 4. Okay, so yeah, this is what CD is. Okay, so now we're ready to find the common perpendicular. Okay, so yeah, just multiply AB, like find a vector product of AB and CD. Okay, so yeah, this time I'm not going to show you what it is like. Okay, I mean, I will show you, but I'm not gonna like elaborate much. Okay, if you need elaboration, you can view the previous part. Okay, yeah. So from here, I'm just gonna do it like quietly without much elaboration. Okay, all right. So I uh, -3, -3, -2, 4 minus J, -1, -3, -1, 4 plus K, -1, -3, -1, -2. So I is -12 minus 6. Yeah, -12 minus 6, that is minus 18. Okay. So -18, 7, -1. You guys can simplify this by multiplying or dividing by -1 across 3 of the components if y'all want. But I think I'm just gonna leave it here. Okay. So yeah, vector. This is the vector of the common perpendicular between the two lines. Okay. Yeah. So now, to find the shortest distance, we're gonna take either point from like either end of both lines, from either end of both lines. So for AB, I'm just gonna choose A, and for CD, I'm just gonna choose C. Okay, and then we're gonna make another line connecting those. Okay, so yeah, the only condition for the line is it has to connect both lines. I mean, it has to connect both ends of the line that are on the same side. Okay, so yeah, AC. You could also do the same for BD as well. Okay, yeah. So here we have to use a bit of trigonometry. All right. So this line, okay, if you like translate it across to here, okay, I think it's not really clear. I think I should redraw the line, or rather just I don't know, extend A. All right. So yeah, this is a new AC. So this new AC, if you translate the common perpendicular such that one end touches here, the other end is here. Okay, translate it. Yeah, so you can see that yeah, the angle between AC and this new translated version of the normal, the angle between them is theta. So if you want to find the shortest distance of this, you just have to find the shortest distance of this translated normal, which is basically the same as the normal that we found in part A. Okay. Yeah, so this normal, I'm gonna let it be n. Okay, so if you want to find that, um, okay, I'm gonna call it modulus of n. Yeah, using your basic trigo, yeah, you can just see that it's just going to be the magnitude of AC cosine theta. Now, the question is, how do we find cosine theta? Okay. Yeah, so luckily for us, right, since these two lines, AC as well as this translated normal, they originate from the same point C, which is also where the angle between these two lines are. We just have to look for an expression that has cosine theta in. And luckily for us, the dot product has cosine theta inside, okay? So yeah, the dot product is just vector AC dotted with the normal equals to magnitude of AC times the magnitude of the normal vector cosine theta, okay? Yeah, so if you make cosine theta subject and substitute it into here, okay, you can do that in your head now. The final expression would be magnitude of the normal equals to magnitude of AC times the dot product of vector AC and the normal over the magnitude of AC times the magnitude of the normal, okay? So magnitude AC over AC cancels out. Yeah, therefore you'll just get the magnitude vector AC times the normal, like dotted with the normal, over the um, magnitude of the normal vector. Okay, so this is the general expression we'll use to find our shortest distance or the magnitude of the normal. Okay, yeah, so let me, okay, you know what? Let's just keep it. Yeah. All right, so let's find the magnitude of the normal. So we first divide by the magnitude of the actual normal, which you found. So that's very simple. You just use Pythagoras theorem. And for the dot product, um, it's good to add a modular sign, okay? Because sometimes the dot product can be negative, and we know that magnitude cannot be negative, all right? So put a modular sign just in case. Okay, so AC, yeah, the reason we chose this is because we already found what AC is. So -1, -4, -6. Okay. You can do BD, but you have to find BD, which I find quite troublesome. Dotted with the normal, -18, 7, -1. Okay, so I'm just gonna simplify everything. Just use a calculator. So this is square root 374. Modulus of this is -1, -18, that's 18, plus -4 times 7, which is -28, plus -6 times -1, which is 6. So you get -4, but luckily put the modulus sign, so it's just 4, okay? And therefore our answer would just be 4 over square root 374, okay? So yeah, this would be our final answer for this part as well as the entire question. And before we end, I know there's like another easier method that doesn't require you to know the vector product. Like you can just use the dot product, but it's a lot more tedious. Like you will get the answer eventually, but yeah, it's a lot more tedious despite it, not requiring much knowledge. I can just use knowledge from A-level maths, okay? So yeah, with that, let's move on to the next question. Okay, so for question 5A, for the first part of 5A, we are told to show that, cosine pi over 12 is equals to this by writing cosine pi over 12 as this first. Okay, so this is very simple. You can just use your subtraction addition formula. Okay, I'm not gonna elaborate much. I think it's cos pi over 4 times cos pi over 6. Yeah, if you don't have it memorized, you can just check your MF19 plus sine pi over 4 cosine pi over 4. So I think cosine pi over 4 is, yeah, square root 2 over 2. Cosine pi over 6 is square root 3 over 2. And sine pi over 4 is square root 2 over 2. Cosine, oh my goodness, I'm sorry, that's cosine pi over 6. Cosine pi over 6 is, wait, no, sine pi over 6, my bad. Sine pi over 6 is half. Okay, so putting it all together, you get square root 6 over 4 plus square root 2 over 4. Yeah, factoring out 1 over 4, you get 1 over 4 times square root 6 plus square root 2. Okay, so yeah, this would be the final answer for this. Let's do the same for the second part. Yeah, so sine pi over 12. Yeah, we're going to use the same technique. So sine pi over 4 minus pi over 6. Okay, so again, if you don't know the sine formula, you can just go back and look at it. So this sine pi over 4 cosine pi over 6. So this time the signs, they match, minus cosine pi over 4 sine pi over 6. So sine pi over 4 is square root 2 over 2. Cosine pi over 6 is square root 3 over 2. Minus cosine pi over 4 is square root 2 over 2. Sine pi over 6 is 1/2. Yeah, so you can see the numbers are the exact same. The only thing that changed is the sign. So therefore, the answer will also just be 1 over 4 times square root 6 minus square root 2. So yeah, this would be our final answer for 5 part A. Let's move on to the next part. Okay, so for the next part, we are told that the matrix M is such that M is equals to this product of two matrices. And in part B, we're also told that M, it represents a sequence of two geometrical transformations in the XY plane. So we have to give full details of each transformation, and we also have to make the order in which they're applied, okay? Yeah. So, yeah. So yeah, first of all, let's see what these two matrices can mean, all right? So the one on the left, okay, including the 1 over 4, yeah, you can see that it's very similar to what we found in the previous part. So the square root 6 plus 2, it's very similar to the cosine pi over 12, and the square root 6 minus 2 is very similar to the sine pi over 12. Same for this, like it's just square root 6 minus 2 multiplied with -1. Okay, yeah, same for this. So this first one is definitely related to, cosine pi over 12 and sine pi over 12. All right, so 1 over 4 square root 6 plus 2. Okay, this one I'm going to write as minus 6 minus square root 2. 6 plus 2. 6 plus 2. Okay, square root. Yeah. So yeah, you can see, like, if you just multiply each of the elements by the 1 over 4 at the front, you'll get the exact trig like ratios. Okay. So the first element That's just cosine pi over 12. Same for this. Okay. Yeah, it's just 1 over 4 times square root 6 minus square root 2, negative. So that's just minus sine pi over 12. Same for this, just sine pi over 12. And same for this is cosine pi over 12. Yeah, so this is what these like mean in terms of geometrical terms, okay? So therefore, M is just this matrix in terms of uh, the trig ratios for pi over 12. And this much simpler ratio. Yeah, so these are the two like matrices that look like geometrical transformations, okay? So the detail, I mean the order is actually from the right first, followed by the left. So this is the first transformation that was applied, okay? So how do we know what this transformation is, okay? So yeah, you can see that these two zeros here, like since they're just zeros, that means there's no shear. So this is definitely like a stretch or a reflection question, okay? Yeah, so this is not a shear if the zeros are like this, because like if there's nothing like done, yeah, it's just this, which is the identity matrix. So if it looks like the identity matrix, like in terms of where the zeros are placed, there's definitely no shear, okay? Okay, so now let's look at which element is like changed. So we can see that this element right here is changed. So instead of 1, it's -1. So um so if the element that's changed is in here, that means the stretch happened in the x direction, so horizontally. And if the number, so this number that is changed, the stretch happened in the y direction, so it happened vertically. All right. And since this number here is slightly changed, like only -1, it's a special case, okay? So whether okay, so if it's your x, that's -1. So this one, if this was -1, um that means it would have been a reflection across the y-axis. So it's a horizontal reflection across the y-axis. Whereas if it's here, it would be a vertical reflection across the x-axis. Okay, so therefore the first transformation we can say is vertical. Okay, never mind, just say reflection across the x-axis. Okay, so yeah, so one way to remember this, rather than just memorizing, is to relate it to your transformations that you learn in your AS level math, pure math 1. Okay, so yeah, try to recall that and try to relate them, and remember it will be a lot easier. Okay, yeah, so the first transformation is a reflection across the x-axis, followed by, okay, so now we have to write the second transformation. So this second transformation, you can see it's in terms of cosines and sines of an angle. And in this syllabus, at least, when, it's in this form, okay, cosine thetas, they're both positive and they're arranged in this way. And one of the sine theta, specifically the one on the top right-hand corner, is negative. This is the only form you would get and have to know for this syllabus at least. It's an anti-clockwise rotation through the angle theta about the origin. Okay, Yeah, so keywords are anti-clockwise by the angle theta about the origin. Okay, don't forget the about the origin part. So we are gonna write followed by anti-clockwise rotation um, by pi over 12, because that's what theta is, about the origin. Yeah, so yeah, these are the two transformations, and I made the order that which they applied. Okay, so yeah, this would be all for this part. And one last reminder, whenever you have like a product of matrices and you have to give details of each transformation applied, the one on the right, on the very right, is applied, followed by the one on the left. Okay, so it's like opposite. Okay, so yeah, just a friendly reminder. With that, let's move on to the next part. Okay, so for part C, we are told to write M inverse as a product of two matrices, neither of which is I. Okay, so for M, we already have an expression like in terms of two matrices, like as a product. So we're gonna let those two matrices be A, B. Okay. Yeah. And for M inverse, okay, like this for any matrix. Yeah, so if M is A times B, M inverse, it will be B inverse times A inverse, okay? So whenever like a matrix is inverse, the product will also like be flipped, okay? So if it's AB, it's going to be B inverse, A inverse, not A inverse, B inverse, okay? Yeah, so this is the rule that we're going to follow. So therefore, we can just write M inverse equals to, so B inverse is going to be this 1, 0, 0, -1 inverse. Yeah, we don't have to exactly work out what it is because they didn't give us enough space for that. And A inverse is going to be the first matrix in terms of the cosine pi over 12 and sine pi over 12. Okay? Yeah, so this is just cosine pi over 12, negative sine pi over 12, sine pi over 12, cosine pi over 12 inverse. Yeah, so yeah, this would be all for part C. Let's move on to the last part. Okay, so before we get started with part D, I didn't complete my answer in part A. All right, so you're supposed to evaluate these completely. All right, so the first one, I'm just gonna do it on my calculator because I'm quite lazy. Um, yeah. No. Two. Okay, so 1, 0, 0, -1. Matrix A. Yeah, so this one is 1, 0, 0, -1. Yeah, it's the same. For this, it's yeah, okay, for this, we're not gonna use a calculator. Yeah, we're gonna use the matrix, like inverse matrix form for 2 by 2 matrices. So for 2 by 2 matrices, okay, let me just get this away. You take the cross product, okay, so it is cos square pi over 12 minus negative sine square pi over 12. So it's cos square pi over 12 plus sine square pi over 12, which is just 1. Okay, so it's just 1 over 1 times these two. So this and this, they have to be swapped. So therefore it's cosine pi over 12 cosine pi over 12. And then these two, they won't be swapped, but they would have negative, these two, they would have -1 multiplied. Okay, so it's negative sine pi over 12 sine pi over 12. Yeah, so, okay, so, God damn, where should I write it? Yeah, so I think we can leave it as this. Okay, I'm just gonna leave it as this. Okay, so yeah, we don't need the one. All right. Yeah, so this would be a final answer, hopefully. Let's move on to the final part. Okay, so yeah, for part B, we're told that y equals to mx is an invariant line of the transformation represented by m. Show that this equation is true. And we also told find the values of m in this form where a and b are integers to be determined. Okay, so this is a pretty unique question, but not so unique at the same time. So we're given an invariant line of a transformation that's represented by m. So to do that, we can just pretend that we are finding the invariant line, okay? So to do that, you first take m. Okay, let's first let's express m in terms of a single matrix. All right. So yeah, m is cos pi over 12, cos pi over 12, negative sine pi over 12, sine pi over 12. And yeah, this one is 1, -1, 0, 0. Let me see if I copied down correctly. Um, yeah, I did. Okay. Yeah, so now we're going to multiply both matrices together to express M as a single matrix, okay? So to multiply matrices, let's get this first element. So to get the first element, on the top left corner, you have to multiply the elements in the first row of the first matrix times the first column in the first row. Yeah, so it's these times these, okay? So yeah, you multiply cos pi over 12 times 1 times negative sine pi over 12 times 0. So that's just cosine pi over 12, okay? And then yeah, for the second one here, yeah, you multiply this row with this, okay? So it's cosine pi over 12 times 0, which is 0 times negative sine pi over 12 times -1, which will give you 0 plus sine pi over 12, which is sine pi over 12. All right. And then for the element at the bottom left corner, you multiply by the elements in the second row of the first matrix times the first row of the second matrix. Okay. So yeah, sine pi over 12 times 1, that's sine pi over 12, plus cos pi over 12 times 0, that's 0. So yeah, this is just, oh my goodness, this is just sine pi over 12. And then finally, for the last one, at the bottom right-hand corner, you just take this and you multiply it with this, okay? So sine pi over 12 times 0, that's 0, plus cosine pi over 12 times -1, that's negative pi over 12, okay? So it's 0 minus cosine pi over 12, which is minus cosine pi over 12. Yeah, so This is M, like in a single matrix. Now we're ready to find the invariant line. Okay, so let's do this. Yeah, so first, this is the coordinates of the transformed, okay, these are the coordinates after the transformation. So that those coordinates, then matrix form, is equals to M times the original coordinates, like the untransformed coordinates, which I'm just gonna write small x and small y. Okay. All right. Now, oh goodness. Okay. Now we're going to substitute big Y equals to small m big X and y small y equals to small m small x. Okay. So yeah, this would just be that. Okay. Um, Now this would just be small x. Yep. And now, yeah, we're gonna multiply those two again. Again, I'm not gonna emphasize on how to do it. If you want a video on that, as well as on how to remember matrices transformations, yeah, please leave it down in the comments below, and I'll make a topical video on that as well. Okay. So yeah, this one is just going to be x cos pi over 12 plus mx sine pi over 12. So it's just m sine pi over 12. This one is x sine pi over 12 minus m cosine pi over 12. Yeah. Now we're just gonna combine it into a fraction. So unfortunately, I have to use the space in here. So to make things a bit tidy, I'm gonna draw a line. Okay, so oh my goodness. So yeah, this is just gonna be x mx equals to, goodness, I have to cram so much. Plus m sine pi over 12 over x sine pi over 12 minus m cosine pi over 12. Yeah, so the x's cancel out. Okay. So now we're going to cross multiply. All right. So cross multiplying would give us m bracket cos pi over 12 plus m sine pi over 12. So that's m cosine pi over 12 plus uh, m square sine pi over 12 equals to just sine over 12 minus m cosine pi over 12. Okay, so yeah, let's just move everything to the left hand side. So we will get m square sine pi over 12, m cosine pi over 12 plus m cosine pi over 12. We get 2m cosine pi over 12 minus sine pi over 12, which gives us 0. And yeah, that is also the equation that we are told to show. So yeah, we're gonna write shown here. Okay. Yeah, I know it's very crammed, but I hope you guys can see like what I'm doing here, right? Yeah, so unfortunately this is not the final part. We also have to find the values of m. Essentially solve the equation. Um, yeah, let's do that. Okay, so to solve the equation, we're gonna use the quadratic formula b squared minus b plus minus b squared minus 4ac over 2a. So b is 2 cos pi over 12. So that's minus 2 cosine pi over 12 plus minus okay, so b squared, that's 4. Oh my goodness. 4 cosine square pi over 12 minus 4ac. So minus 4. A is sine pi over 12. C is negative sine pi over 12. So minus 4 times sine pi over 12 times negative sine pi over 12. That's plus 4 sine square pi over 12. Okay. So plus 4 sine square pi over 12. Okay. All over 2a. So 2 sine pi 12. Okay. All right. So let's um simplify the square root. So the square root, it actually just says 4 cos square, cos square pi over 12 plus 4 sine square pi over 12. Okay. So you can factor out the 4. So you get 4 times cos square pi over 12 plus sine square pi over 12. So cos square plus sine square, that's just 1. So in reality, it's just square root 4, which gives you 2. Okay? Yeah, and then, yeah, now let's just split up this. Okay? So you get minus 2 cos pi over 12 over 2 sine pi over 12 plus minus, so square root 4, that is 2 over 2 sine pi over 12. Okay, so the 2's they cancel, so you get minus cos over sine, which is cotangent. Okay, so it's just minus cotangent pi over 12 plus or minus. Okay, the 2's cancel out, so I get 1 over sine, which is just cosecant pi over 12. Okay, so therefore m is either minus cotangent pi over 12 plus cosecant pi over 12 or minus cotangent pi over 12 minus cosecant pi over 12. Okay, so yeah, these two would be our final answers for the last part. Let's move on to the next question. Okay, so for this question, we are told that the curve C, it has a polar equation r equals to cosine half theta, where theta is between 0 and pi. Okay, so this is the range. So using that, we have to sketch C. Okay, so to sketch a polar curve, you always start with your initial line and you label it as theta equals to 0, right? So you can either like just create a table of values, or you can, substitute different values of theta and keep it in your head, or put it in a table and sketch until theta equals to pi. Okay. Yeah. So cos half times 0. Yeah, you get 1. So 1. And then, yeah, you increase the angle slightly. I'm going to increase it to pi over 6. Okay, so I get 0.96592. Yeah, that's slightly lesser than 1, so it goes like around here. And now I'm gonna switch to theta equals to pi over 4. Okay, slightly lesser, 9238. Yeah, it didn't decrease that much. Okay, now to pi over 3, which is 60. Okay, 0.86. It's a much more rapid increase. So yeah, probably here. And yeah, finally uh pi half or 90 degrees. Okay, that's 0.7. Yeah, which is around here. Okay. Actually, I think I should put it here because it's smaller, right? So it's supposed to be here. And then yeah, I'm just gonna immediately just increase it to pi. Yeah, it's just 0. So therefore, it would roughly be like this. Okay, it will roughly be like this. It'll roughly be like this. Okay, so this is C. Okay, so yeah, this would be our final answer for the first part. Let's move on to the next part. Okay, so yeah, for parts B and C, yeah, we're given these identities to use. Okay, so for part B, we are told to find the exact value of the area of the region enclosed by C and the initial line. Okay, all right, so to find the area enclosed by a polar curve, you have to know this formula by heart. We use half integral of r squared d theta. And the limits would be with respect to theta, the least value of theta, and the upper limit, which is pi. Okay. Yeah. So yes. So r square is just cosine square half theta d theta. Okay. So to differentiate it, okay, yeah, good. We have a identity here to help us. Okay, so yeah, just make cosine square half theta the subject. So I can do this in my head. Cosine square half theta is just cosine theta plus 1 divided by 2. So half integral from 0 to pi of cosine theta plus 1 over 2 d theta. Okay. Yeah, so the half, we can move it out of the integral sign. So half times half is 1 over 4 integral of pi 0 cosine theta plus 1 d theta. Yeah, so yeah, integrating this is really simple. So cosine theta, you integrate, you'll get sine theta plus yeah, 1 integrate, you just get theta with respect to limits. Yeah, now just substitute your limits in 1 over 4 sine pi plus pi minus sine 0 minus 0. Okay, so sine 0, that's just 0. So this just 0. This is also 0. And sine pi is also 0. So it's just 0. So you just get 1 over 4 times pi, which is just pi over 4 units squared. So yeah, this would be all for part B. Let's move on to part C. Okay, so for part C, we're supposed to find the maximum distance of a point on C from the initial line. Okay, so we're supposed to find the maximum distance from the initial line. Okay, so let's go back to our curve. Okay, so this is the initial line, and this is the distance, like the maximum distance. Okay, so what they just mean is to find the maximum vertical distance, and like whenever like we have to find anything vertical related, is a maximum. Like you should always think about the the y-axis, okay? So the maximum y point. Yeah, that's what we basically have to find. Okay. So to find that, we have to know um the expression for y in terms of theta, and using that to find dy d theta, and equating to 0 to find the exact value of theta for which we can get the maximum distance, um, by substituting that value of theta back into the expression for y in terms of theta. So I know that's a lot, so let's just, do it. Then you'll actually understand. Okay, so let's find an expression for y in terms of theta. So you must know this, okay, that y is r sine theta. This is one of the equations for polar curves, okay? This can be demonstrated using a simple diagram, all right? Yeah, so this is your r, and this is your y-axis. Okay, then using Pythagoras and trig, yeah, you can see how y is r sine theta. Okay, so yeah, now we're just gonna find y equals to okay, r is cosine half theta. And yeah, so y is cosine half theta sine theta. And okay, to make things easier, I think we have to express sine theta in terms of half theta. So you for that, we can use this identity here. Sine theta equals to 2 sine half theta cosine theta. Okay, so y is cosine half theta times 2 cosine half theta sine half theta. Okay, so yeah, y is just going to be 2 cosine square half theta sine half theta. Okay, so this cosine square half theta, we're going to 2 sine half theta. Yeah, we're going to express it in terms of sine theta so that, when we differentiate later, it's going to be easier for us. Yeah, we're going to use the cos square plus sine square identity. All right. So yeah, this one's just going to be 1 minus sine square half theta. Right. So yeah, this is going to be y equals to 2 sine half theta minus 2 sine cube half theta. Okay, yeah, now we're ready to integrate, so let's just integrate it. All right, so let's integrate this first so we can keep the 2 out. So we just have to integrate the sine half theta. So to integrate trig functions, we first just focus on the trig function itself. So you just differentiate the sine. So you keep the half theta. So therefore it's going to be cosine half theta. And after that, you differentiate like the theta. So the theta in this case is just half theta. So differentiating, you'll get half. Okay, so this is just going to be half cosine half theta. Okay. Yeah, and then for the next one, it's a bit more complicated. So as usual, you can keep the 2 out. So yeah, now we're gonna differentiate the sine cube half theta. Okay, so to differentiate that, you first have to bring down the power. Okay, but this is according to the chain rule. Okay, so you bring down the power. So 3 sine square half theta, and then you differentiate the trig, which is just sine half theta. So you differentiate trig, you'll get cos half theta, and then you differentiate the theta, which is half theta, with respect to theta, which is just half. All right. Yeah, so that's all. Okay, so this cancels out, this also cancels out. So therefore, final answer will just be cosine half theta minus 3 cos half theta sine square half theta. Sine square half theta. Yeah. Yeah, so this is dy d theta. And now we have to equate it to 0. Okay, so cos half theta minus 3 cosine half theta sine square half theta equals to 0. So we'll factor out the cos half theta, then you get 1 minus 3 sine square half theta equals to 0. Okay, and then you just equate both factors to 0. So cosine half theta is equals to 0. So yeah, just simply solving it and taking into account the range, which for theta is 0 and pi. So for half theta, it's going to be 0 and pi over 2. All right. So this can only be, oh my goodness. So, okay, so this can only be equals to pi over 2. Yeah. So therefore, theta has to be equals to pi. But we know that's not the case because, yeah, the distance is literally at the origin. Okay, so therefore we have to reject this, unfortunately. So yeah, on to the next one. So 1 minus 3 sine square half theta equals to 0. So I'm just gonna straight away just solve for sine square half theta. Yeah, which is just 1 over 3. All right. Okay, and now, okay, so our main purpose is to find the corresponding y value for this value of theta. Like we don't have to find what theta exactly is. Like, okay, so you can see in this version of the expression for y in terms of theta, you just have to know what cosine square half theta is and sine half theta is, okay? So yeah, we actually can find cosine square half theta using cos square plus sine square equals to 1. So cos square half theta is just 1 minus 1/3, which is 2/3. And sine half theta is just square root of 1 over 3. And there's no like negative version of this because, as I said, the range for theta over 2, since the range for theta is 0 and pi, the range for theta over 2 is pi over 2. Yeah, 0 and pi over 2. And that is entirely in the first quadrant, so that means sine cannot be negative. Okay? Yeah. So yeah, these are our answers. And yeah, using this, we are going to find the maximum value of y. Okay, so yeah, let's just say sub cos square half theta equals to 2/3 and sine half theta equals to square root 1/3. Okay. Actually, yeah, let me do this in the next line. Okay, so y equals to 2 cos half squared. So that is just 2/3 times sine half theta, which is square root 1 over 3. So that is equals to 4 over 3 square root 1 over 3 units. So yeah, this would be our final answer for the last part as well as the entire question. Let's move on to the final question. Okay, so for this final question, we're told that the curve C, it has this equation. Okay, so for the first part, you have to find the equations of the asymptotes of C. Okay, yeah, so okay, so to find the asymptotes, you start off by finding the x asymptote, okay? And then the vertical asymptote. And to find the vertical asymptote, you have to equate the denominator to 0, okay? So that's the simplest. You just equate it to 0 and make x the subject, okay? So you get 10x equals to 18, and x would just be 18 over 10, which is 9 over 5. Yeah, so this is the vertical asymptote. Yeah, and now we have to find the horizontal slash oblique asymptote. In this case, it's an oblique asymptote because the function that we're given is an improper fraction, all right? So whenever you have, whenever you have an improper fraction, there'll always be an oblique asymptote, okay? And to find the oblique asymptote, um, one way to do it is to, just do long division. All right, so that's what we're gonna do. Okay, so 10x squared minus 11x minus 18. So I'm not gonna elaborate on the long division part. Okay, so it's gonna be 10x squared plus x minus 18x. So minus 11 plus 18, which is 7x minus 18. That is going to be, okay, 7x. Okay, to make it 7x, to multiply by 7 over 10. So 7 over 10, 0.7 times 18. That is 63 over 5. So, okay, 63 over 5 minus 18. That is 27 over 5, like as a remainder. Oh, and then the number that's multiplied here is 7 over 10. Okay. Yeah. So so therefore, y, we can express it as the quotient x plus 7 over 10 plus the remainder, which is minus, wait, uh which is minus 27 over 5 over 10x minus 18. Okay. So this part we don't have, you can ignore. All right. Therefore, yeah, the oblique asymptote is just y equals to x plus 7 over 10. Yeah. So yeah, for oblique asymptotes, yeah, once you do the long division, you just take the quotient. All right. Yeah. So these are the final answers for the first part. Let's move on to the next part. Okay, so part B just tells us that to show that C has no stationary points. All right, so to show that, we just have to find the expression for dy dx in terms of x. I mean, yeah, of course, and equate it to 0. All right, so yeah, let's find. Yeah, let's take this version. It's a lot easier to differentiate. So x plus 7 over 10 minus 27 over 5, 10x minus 18. Okay, so dy dx, just differentiate this first, which is 1. Differentiate this, that's 0. and differentiate this. Okay, you remove the 27/5 and you will differentiate 1 over 10x minus 18, which is just 10x minus 18 to the power of -1. Okay, so this one is 1 minus 27/5. Yeah, so you just bring the -1 forward. So 10 minus 10x minus 18 -1 is -2. And you differentiate 10x minus 18 with respect to x, which is just 10. Okay. Yeah, and you plus 27/5, 10, and x minus 18 to the power of -1 plus, oh my goodness, 1 plus 270/5, 1 over 10x minus 18. Yeah. So 1 plus 270/5 times 10x minus 18 squared. Yeah, now we just equate it to 0. All right, so 1 plus 270/5, I think. Yeah, that's just 54 over 10x minus 18 squared equals to 0. And 54 over 10x minus 18 squared is equals to -1. So, okay, so let's just make okay, let's continue here. Let's make 10x minus 18 the subject. Okay, so 10x minus 18 squared equals to -54. However, you can see that, this is a squared like term. Okay, it's a perfect square, and you know that perfect squares, they must be positive. So therefore we can say no real solution. And back to here. Therefore, dy dx not be equals to 0 and no stationary points. So yeah, this would be the final answer for this. Let's move on to the next part. Okay, so yeah, here we just have to sketch C, stating the coordinates of the points of intersection with the axes. All right, so to do that, let's just sketch the axes. So the x-axis and the y-axis. Okay. Yeah, so okay, so to do this, let's first sketch the vertical asymptote, which is x equals to 9/5, which is x equals to 1.8. So 1.8 should be around here. Okay, so yeah. By the way, for this, I suggest that you guys use a ruler, but right now I don't have a ruler, so I have no choice but to use freehand, unfortunately. Okay, now let's sketch the oblique asymptote y equals to x plus 7/10. All right, so with the 7/10, obviously the y-axis, oh my god, the y-axis is supposed to be here. All right, and the the y-intercept is supposed to be here, and the x-intercept is supposed to be here. So, oh my goodness. Oh my goodness. Uh, oh shoot. I don't know what's going on. It's acting a bit funny. Okay. Okay, yeah, as you can see, it's not perfectly straight, but it's the best I can do. So this is y equals to x plus 7 over 10. Yeah, so hmm, yeah, that's what you have to do. Uh yeah, so as you guys know, there's no like stationary points. All right. And now we're going to just quickly state the coordinates of points of the intersection. Okay. So to find the y-intercept, I'm just going to uh, just gonna type in everything into my calculator. Okay, that's just one. All right. Yeah, that's just one for the y-intercept. So I guess yeah, it's right around here for the y-intercept. So yeah, y-intercept is going to be 0, comma 1, and x-intercept, okay, x-intercept, there has to be 2 or none at all. It's probably going to be 2. Yeah, x-intercept is just this equals to 0. Okay, so it's 2. Okay, so 2 is right around here. So it's 2o and negative 9 over 10. So that is minus 0.90. Okay, so should be slightly around here. Okay, yeah, so these are the points of intersection with the axes. Okay, so with that in mind, we can finally start sketching. Okay, here we go. Yeah, okay, and then this one is, yeah. So these yeah, so this is our sketch of C, okay? Yeah, I think it's good enough. Yeah, it fulfills all the conditions. Yeah, I think, yeah, we can stop here for this part. Let's move on to the next part. Okay, so for this part, we are told to sketch the curve with this equation. So it's basically the same equation as we sketched just now, but this time the whole thing has a modulus sign outside of it. So what that does to the graph, like visually, is that everything that is below the x-axis gets reflected above the x-axis, okay? So everything that's negative, like everything that has a negative y value, will have opposite positive y value. Okay. Yeah. So basically everything that is above the x-axis, I mean, below the x-axis will be reflected above the x-axis. Okay. So yeah, I'm just gonna, yeah, so it's like this. Yeah. So you can see it's like this. So it'll be like this. Yeah, it'll be like this. And yeah, for this, it's gonna just shoot up. I think, yeah, it's gonna shoot up, I think. Yeah, it's just gonna shoot up. And this one is gonna be nearly vertical. Okay, wait, nearly vertical. Yeah, so this is the vertical asymptote. I mean, it's not necessary to like draw it, but it's still, a good habit. Yeah, and then this is approximately the oblique asymptote. Yeah, so this is roughly what y equals the modulus of the equation that we drew just now looks like. Okay. Yeah, so with that, let's move on to the last part. Okay, so for the last part, we are told that given that this, like the graph that we drew previously, is less than 4 for these values of x, so x being between this lower bound and p being the upper bound, as well as this second set of x being between q and this, we have to find the values of p and q. All right, so okay, so to do this, let's just pretend that we have to find these ranges first, okay? So like usually the question that they ask here is that given that it's like this, find the set of values of x, and we have to give the ranges like this. But now they've reversed the question. So we have to work backwards, okay? So let's just do the question as if we're trying to find the range, all right? Okay, so to do this question, you replace the inequality sign with an equal sign, then you would know the critical points, okay? So yeah, just do that. 10x minus 18 equals to 4. Okay, so 40x minus 72 equals to 10x squared minus 11x minus 18. 10x squared minus 11x minus 40x is 51x plus 72 minus 18, which is 54. Yeah, that is equals to 0. Okay, so all right, let's see what that gives us. Okay, so that one, since that's the lower bound, okay, and like we didn't put the negative sign, it has to be these points, okay? So actually what would be helpful is if you draw like a line and you set this y equals to 4, and then these would be your intersection points, okay? So all these like limits right here, these are actually intersection points, all right? So uh so you can see like for the ones that they gave us, they're like, how do I say that? Conjugates of each other, right? So that means they must have been obtained from the same quadratic equation. Okay, actually, let's just see. All right, so 10 minus b plus minus b square minus 4ac over 2a. So yeah, this one just gonna 10 minus 51 plus 54. Oh, yeah, that's gives us really nice whole numbers. 18 over 5, as well as x equals to 3 over 2. Okay, so that means these answers that they gave us here, you will get it when you equate 4 with minus this whole thing. Okay? Yeah. So I don't think that's like really necessary. All right. Yeah, so we found our P and Q, but we don't know which one is P and Q. So now we're just gonna use our graph that we drew here, all right? So yeah, by comparison, I think 3 over 2 is 1.5, 18 over 5 is 3.6. Okay, so the 3.2, yeah, so this is the 3 over 2, and this is the 18 over 5, yeah, 3.6 at 18 over 5. Yeah, 3.6 and 3 over 2 and 1.5. All right. Yeah, so yeah, this is P and Q. Okay, now we have to see which of these, of the limits that they gave us, is the negative one and which one is the positive one. Because for the two unknown ones, one of them is negative, one of them is positive, okay? So I think it's pretty clear, but I'm still going to check anyway. Yeah, so this is the one that's negative, so therefore P is 3 over 2, all right? So how do I explain? So therefore, P is 3 over 2 since P is upper limit of range that starts with a negative number. Yeah. And therefore, by process of elimination, Q has to be 3 over 2. Yeah, I hope they accept this. Wait, no, actually, I don't know, just to be safe, we should do, the negative 10x squared. Yeah, just to be safe, we'll do that as well, because I have a very uneasy feeling that they might not accept it. And it's quite hard to explain it in words. Okay, yeah, so just gonna my goodness. Yeah, minus 10x squared plus 11x plus 18, 40x minus 72. Okay, so 10x squared plus 29x minus 72 minus 18. Yeah, that's minus 90 equals to 0. And then, yeah, x would just be minus 29 plus minus b squared minus 4ac over 2a. Yeah, so therefore it will just be minus 29 plus minus plus minus 441 square root 4441 over 20. Yeah. So yeah, this is the other value of x, yeah, which we cross-checked. And yeah, therefore P is 3 over 2 and Q is 18 over 5. Sorry, yeah, 18 over 5. So just give me a while. Okay, so yeah, we're actually done with this last question, and we have come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe for more A-level maths and further math past paper solving videos, as well as topical videos, which I'm planning to release soon. If you're interested in them, please let me know what topics you would like me to cover in those videos. And if you have any questions, any feedback on how I can improve, or if you want, any tuition classes, please feel free to, leave it down in the comments below, and I'll get back to you as soon as possible. And I will see you again next time. Okay, thank you.